Hi guys, good morning. Welcome to week number 5 of System Administration course. We're gonna talk about today memory management, and we're gonna start bash scripting basics today as well. So I'm gonna go through some theoretical parts in the beginning, and then we'll jump to the practical part as always. So I'm gonna spend less time on memory management because we have already seen memory management in week number 3 and some part of memory management when we were using disks as well. So we have done quite a bit about this. I'm gonna just talk about virtual memory and swap memory today, and then I'm gonna explain you what bash is, and we're gonna do very basics of bash scripting today. um, as a system administrator, you should know bash commands. We have already been using a lot of bash commands like ls, like rm, and cp and mv and so on. Many other bash commands we have been using. So uh, what bash scripting is, how we use bash scripting, and why this is so useful, why it's very beneficial for system administrator to know these bash scriptings. We'll talk about that, and we'll do a lot of exercises today. I'll try and go through in this lecture all the basics of bash scripting, and then we'll see if we can. I have a set of exercises prepared for you as well for bash scripting as well. I'll do a couple of them for you so that you actually get an idea of how to do it, and I'll try and leave the other ones for you to try at home. So this is what we are going to do today. And for memory management, this is chapter number 6 of your book. For bash scripting, I'll provide a link where you can find a lot of information on bash scripting. Even if there is no link, you can just Google bash scripting basics and you will find so many tutorials. If you write something like this on YouTube, you will find a lot of videos on YouTube, and they are excellent videos. So I would really like you guys to spend some time on learning bash scripts, because coming assignments and some of the things maybe in week number 7, even in week 6 for system monitoring, we might be using bash scripting to do a lot of things. So you need to get some idea of what bash scripting is, why we use it, how to use it. So you need to know all of these things. All right. So that's for this. I have received assignment from a lot of students. I have to check how many are left. So if you have not submitted your assignment, and obviously the deadline is over now, please contact me and we'll discuss how to go from there. So please do that. And we have another assignment coming up maybe next week or next to next week, but we will try to follow this flow, because then we have a project, and then we have another assignment coming up. So we'll try to follow this course flow. So let's get started with our today's lecture. So it's about memory management for system administration. We start with a concept called virtual memory. We all know what virtual memory is. If you don't know, let me quickly explain what virtual memory is. So basically, if we want to run our programs in an operating system, we need to bring that program into our RAM, into our main memory. So if program is not in the main memory or RAM, it cannot run. So if a program is running, it means that it is in the RAM, it is in the main memory, and operating system is running that program. So sometimes, now obviously your RAM is limited. It doesn't have as much space as your hard drive has. For example, RAMs are maybe 2 GB, 4 GB, 16 GB, somewhere around that. But your hard drives are in terabytes, right? So you can use a lot of space in your hard drive, but for RAM you cannot use unlimited space, or spaces in terabytes. So RAM has to be used very efficiently, very wisely by the operating system, and that's what operating system does. Operating system makes sure that it uses this RAM very carefully, very wisely, so that you as a user do not see any lag, any slowness or lagginess in performing your operations on computers. So since RAM is very limited in its space as compared to hard drive, there is a lot of chance that RAM might get filled, because you might have a lot of programs running, and not only those programs, some of the services in the background are running. For example, your antivirus program is running in the background. It might not have a graphical user interface that is running, but it is running as a service in the background. Similarly, your email client, it's running in the background. So they all need some space in the RAM. So there is a chance, and it might happen, that your RAM space, your main memory space, gets over very quickly. So in that case, what happens is, since it's a hardware, RAM is a hardware, operating system cannot just bring another hardware and put it into your system. So what it does is it makes use of the current installed hardware in the system to get some more space. For example, it chooses a part of your hard drive as a RAM and uses it as a RAM, right? So what it does is, I'm just giving you an example. For example, if your RAM is finished, it will use, operating system will use a part of your hard drive, maybe 1 GB, or you can assign that as well as a user. It can use 1 GB of your hard drive and place the files over there and run programs from there. Now, what is the problem? Why don't we use a hard drive then instead of RAM? The problem is hard drives are very slow as compared to RAMs. RAMs have a very high speed. If you remember, we discussed it in the beginning of this course as well, and we discussed the memory hierarchies as well. So RAMs are pretty fast, and hard drives are quite slow as compared to RAM. So we cannot keep on running programs from our hard drives. We need a very fast RAM, very fast memory to run our programs. So for some programs, yes, that they can be placed if they are maybe running in the background. They are not always showing the graphical user interface. Then what operating system does wisely is it takes those files from the RAM of that program and puts it into the virtual memory, which is the space in the hard drive, and uses that space. And when the program is again active, it brings those files from hard drive to your RAM very quickly, right? So this is what it does. This is what virtual memory is. Now, the part of hard drive that is used as a virtual memory is normally called as swap space, because what operating system is doing is just swapping the files from RAM to hard drive and then from hard drive back to the RAM. So that's why it's called a swap space. So I hope you understand the concept of virtual memory, and obviously as a user you can assign the space of virtual memory to your computer as well, and operating systems by default they have some virtual memory spaces as well. Now there are two ways in Linux how virtual memory is managed. One of the ways is to use the file system as a normal file in Linux, to use that as a virtual memory. And another way to do that is that operating system creates a separate partition for swap space. So for example, you have 50 GB of hard drive. What Linux can do is it will take 1 GB of space from 50 GB and use that as a swap space. So make it a separate partition and use it as a swap space, and no other file will be placed in that partition, right? The other way to do it is a simple way. It uses it doesn't partition your hard drive. It uses maybe your C drive or D drive. Normally we don't have CD drives in Linux, but just to give you an idea, it uses your drives, some drives, to place a file in that, and that file is then used as a virtual memory or a swap space. So these are two techniques which are used by Linux to use virtual memory or to use swap spaces in the operating system. Now, what is the difference between these two things? So one is the normal file and the other one is to create a separate partition. Now the partition would be faster, of course, because there will not be other files. The partition is all clean. It's only for swap space. So operating system doesn't have to go here and there to search for the files that are used for virtual memory. So it's much faster than if you have a file on the normal used partition. Obviously, normal used partition, it will have your own files as well. It will have operating system files as well. Then it will start having the swap space files as well. So it will take some time for operating system to distinguish between them, to bring those files, and so on. So swap partitions are much faster than having swap files, but the problem is swap partitions are difficult to partition. If you want to later on increase the space of your swap partition, you need to do some steps. I mean, you need to increase the partition. You might have to do the partition again, which itself is a big hassle. It's not easy to do partitioning. If you remember, we did some partitioning last time. I told you how to do it, and you might have seen that there are a couple of steps involved, and you might lose data when you start doing partitioning again. So the advantage of using a swap file is you can increase the size because it's on the regular partition. It already might have enough space, so you can increase the size of swap file. But increasing the size of a partition might require you to partition again. So these are the differences between a normal file, using a normal file as a swap space and a partition as a swap space. Now obviously you can use both of them at the same time, that's not a problem. So that's for this. And how to create a swap space. System administrators are given flexibility of creating their own swap spaces, so you can create a own swap space as a system administrator, and the command used for that is mkswap, which is make swap, and this will be on local disk. So if you want to do a mkswap on an external drive, it's not possible. I mean, it's still possible by doing some tweaking here and there, but it's not a good idea to do that because external drives are already very slow. So they are slower than your hard drives as well. So it's not a good idea to do that. And the command used for that is this one. I'm not going to do this today because obviously it requires having a swap space, and then giving a demonstration of this is very difficult because then you have to make your operating system place some files in the swap space, and operating system, it's not easy to ask operating system to use a swap space because you have to then fill your RAM, only then your swap space will be used. So I'm not going to give you a demo of doing that, but this is the command, obviously, how you can use a swap, how you can create a swap space using dd command. And then obviously you can name that, so you can call it extra swap, you can name it, and you can provide the size and so on. Linux, what it does is Linux memory Linux memory manager, it has a limit on how much space you can create for each swap space. So each swap space can only be 2 GB, but you can create 8 of them, right? So at the same time you can create 8 of them. So basically you end up having 16 GB of swap spaces, but this is not going to be a single swap space. There will be 8 swap spaces, which will serve the purpose, I guess, because obviously you are not going to use swap space every now and then. It will only be used when it is required by your operating system, because you are running out of your RAM. So these are some of the facts, statistics on using swap spaces. Then once the swap space is created, you need to tell kernel that okay, I have created a swap space for you. If you want to use, if you run out of your RAM, you can use this swap space. And in order to tell operating system that, you do a swap on. You have to run this command, and you have to tell your operating system that okay, this is the name of the swap space I created for you, and this is where it is. And you tell this by using a swap on command. So this is a keyword, it's a command, it's a utility, and then you specify your swap space for the kernel. So when you run this command, kernel gets the idea, okay, I have a swap space created for me, so if I run out of RAM, I can always use this space as my virtual memory or as my swap space. And you can always turn that off using swap off. If you think that I have just wasted my memory and my RAM is not being used too much, I don't have enough problems with you filling up my RAM and so on, so you can always turn off your swap space using swap off command. So you can always do that. Then this swap space can be used by different operating systems. So you might have a server, and that server is attached to different other machines, and the space in the server is being used by different operating systems in different machines. So you can create a swap space on the server, and different operating systems can share that swap space. It can happen, but it's a bit tricky because it requires a lot of knowledge from grid computing and so on. So I'm not going to go there, and obviously this is not part of our syllabus as well. But if you want to read more about it, you can go to this link and you can read about that. But just to give you an idea that a server can share its swap space with its clients, with its fellow servers as well. So it can do that. And how to do that? Obviously, I mean, these are the steps, but again, I have given these steps to you just to read them, but this is obviously not included in your syllabus. We are not going into that, but these are just the abstract steps of how to calculate the swap space. But normally an administrator actually knows how much swap space it is going to allocate, and because you know as a system administrator that how many resources would you require, right? So nobody else can tell you that, but these are just abstract steps that you can use. These are just standards which are being used throughout the world, but obviously as a system administrator you don't have to go through all of them. you can guess how much space you need, and you can allocate that much swap space for your system. Then next concept is about buffer cache. We know what a cache is. What cache does is, let me give you a not from the operating system, let me give you a general idea of what a cache is. So for example, if we are using a browser and we are using some files again and again and again, right? So we are using some websites where there is a login name and a password, and that is being used again. I do that every day, and so on and so on. So that what browser might do is it will save that file in its cache, in its memory. So it will have some memory, and it will save that from there, instead of taking it from your hard drive every now and then. So that, because cache is very fast. If you remember, we did that in our starting lectures, that the fastest memory is the register memory, then the cache, then RAM, and then hard drive, and then so on, right? So cache is very fast. So if you want some of the commands to run very fast, you can keep that in cache. Well, operating system does that automatically. For example, ls command for listing the contents of a directory. If this command is being used a lot, maybe 10 times or 15 times in 1 hour, what operating system will do is operating system can save this command in the disk buffer, right? Because operating system knows that, okay, this command is being used a lot, so operating system doesn't have to go to hard drive and bring this information from hard drive every now and then. So operating system can, operating system can do is it will save this information in the cache. It's also called disk buffering. So there is a buffer or a cache where the information is stored and quickly fetched from there, instead of going to the hard drive and fetching everything from there, right? And obviously the memory that is used for this purpose is called buffer cache, right? So and this is cache concept is exactly similar what we use in our normal life, which we use in our computing, everyday computing, and it's very similar over here. And there are two types of buffer cache. So what can happen is, buffer cache obviously is not too big, and it doesn't have to be too big, because then again the problem will happen. If cache has so many things inside, then there is the same problem of why not to keep everything on the hard drive if you have to search within the cache as well. One of the reasons why you are bringing stuff from your disk to a cache is that disk contains a lot of files, so operating system doesn't have to take too much time to search out of those files. Cache, it has small amount of files, so operating system doesn't have to spend a lot of time searching for those files within that cache memory, right? So if that is too big, then we fall into a same problem of searching through all these files, right? So it's always a good idea not to have cache very big, and normally is not very big. So operating systems normally have two types of cache. So what it does is, there is a write through and there is a write back. In write through, what happens is the data is written at the disk at once. So for example, there are 4 utilities that you want to use again and again, ls, maybe remove, and so on. These are written, all of them are written at once in your cache, right? And this is called a write through. Write back means that those are written one by one, maybe later. So one is written now, the other command is other utility is written later, and so on. So these are just the ways of writing to your cache. So some of them are written at once, some of them are written later, one by one. So these are called write through and write back. So these are the few concepts I wanted to go through, because these were not covered in any other topic we have covered. So we have given an overview of memory management here, we have given it over here in week 4 as well, but these concepts we did not cover anywhere. So I wanted to cover these topics. Otherwise I actually wanted to spend a lot of time working on bash scripting basics today, but just wanted to make sure that we don't miss anything. That's why I took some time to cover this over here. So I hope memory management is clear now. Memory management, and I think you guys have already gone through operating system course, where memory management is a big topic, and it takes around 3-4 weeks to complete this topic, sometimes more. So that's why I'm not going into a lot of detail, and obviously this is not only few of the concepts of memory management are required in in this course, so I'm not going into a lot of detail of this. So what I want to do now is I want to move to bash scripting basics now. So what I want to do is I'll just maybe go to my virtual machine and start writing code over there. But before I do that, what I can do is I can actually there is some I have some slides for you, very quick slides, 1 or 2 slides, just to tell what a shell is, just to tell you what a shell is, what is scripting, and that's it, and then we'll move to the technical part of it. So what a shell is, we already know what a shell is. A shell basically is an interpreter of user commands, right? So whenever we are writing ls or rm, we are basically writing commands on our shell, on our terminal, and what shell does is it interprets the commands we provide and then performs actions, right? So this is what shell is. It reads commands one by one, so we write one command, it will do that. If we want to have a sequence of 5 commands that we want to run one after each other, we can save that in a file. We normally call that a shell script or a shell program, and then we execute that program. So instead of running one command each time on our prompt, on our terminal, we can write couple of commands, a lot of commands maybe, inside a file, and then we run that file, and those commands will be run. So this is what we are going to do today, and that is called basically shell scripting. And now there are a lot of shells installed in different distributions, and there are different types of shells. So there is a Bourne shell which is the sh, and there is a bash shell which is very famous, and we're going to use that. And then we have a C shell also, which uses C commands as well, and there are many others but I'm not going into detail of all of them. We're going to work on bash. It's one of the most popular ones, and it's just a variation of sh. It contains a lot of features which sh doesn't contain even. So it's built on sh, obviously. It's just an extension of sh, and it adds more features to it. So that's pretty much it. What I'm gonna do is I'm gonna quickly go to my my virtual machine now, and let's see what shells do I have installed on my system. So for that, what I can do is I can use a cat command, and I can use to go to etc directory, and shells are available over there. So if you see, if I do something like this, so I have sh, I have bash available, and so on and so on. So I have a couple of shells available. I'm going to use bash over here, so I'm not going to go into other shells. So let's talk about this. What I'm going to do is I'm going to write a very simple program, a shell script, because we have already gone through the commands. For example, we know ls command, we know remove command, we know the basic commands in our shell. What I'm going to do is I'm going to write shell scripts for you, bash scripts for you. So this is what we're going to do today. All right, so let's start doing that. I'm going to use Sublime editor. You can use any editor you want, and for this I'm going to do let me say hello underscore script dot sh. So it has to be sh. So the extension of your script needs to be sh. All right, so this is how you do it, and you save it, right? Okay, so first of all, the first thing you need to do is you need to tell your bash, because I'm going to use bash, which script you are going to use, which scripting language you are going to use, right? So for that, the first line in your scripts is always going to be hash exclamation mark, then slash bin slash bash. So I am going to use a bash script over here, so that's why I'm going to use this command. Okay, but if you want to use sh, you replace bash with sh. So every time you're going to write a script, first line has to be this, otherwise this will not work for you. All right, so make sure you do it this way, and obviously this is going to tell your terminal in journal that I'm going to use, okay, I'm going to use this file, and since it says slash bin slash bash, which means that I'm going to use a bash script. So I'm going to compile, interpret all of these commands using bash. All right. So this is what I'm going to do. So first thing first, I'm going to do an echo. So let me do quickly first of all here. So if I do echo, if I do hello world, it's going to display me hello world, right? So we know echo, we know this, we did this, right? I'm going to use the same thing over here. So if I do echo and if I do hello world over here, if I save this file and then I go to my terminal because I have to run this. Now there are 3 steps when you are running a bash script. First step is to write the script. Okay, we are done writing this. Then you need to make sure that you give an executable permission to the script. All right, executable permissions to this script, otherwise this will not work, because when we write our script, we are going to execute that script, right? So when we execute that script, only then that script will be executed and gonna show us the output, right? So we have written the script. Now the second thing is to give permissions to execute this script. So I'm gonna do chmod, and we discussed this, how to give permissions. And since I'm going to give an executable permission, I will do +x. You can use 755 number or other numbers as well, depending upon what permission you want to give. But this is the easiest way to give the executable permissions to your script. And then I'm going to say, what is the name? It's hello script. So I'm going to say hello underscore script dot, first of all, I need to go to my directory. So I have to go to my temp directory. And over here I have to give my permissions, +h hello underscore script dot sh, and the permissions of executable is provided to the script, right? If there is an error, you will get an error. In this case there is no error, and the way to run your script is to simply execute it. And this is how we execute files in terminal, right? So I'm gonna do this and I'm gonna type the name of my script. So, and it displayed as hello world. This is exactly what we wanted. So these are the 3 steps which you have to follow in order to run your or execute your shell script. First thing is to write the script, second thing is to give it a permission, and third thing is to execute that, right? So this is how it works. And very simple. What we did is we simply displayed a message, a very simple hello world script we have written. Now sometimes what we want to do is we want to maybe write something inside a text file, maybe. All right, so I'm gonna go very slow so that you guys actually understand how this works, right? You might think that these are very simple things, but I want to go very slow, and then I'm gonna take the pace. So next thing what I want to do is I want to save something in a file, right? So if you remember, I'm gonna do it over here instead of just writing everything on the terminal. So I want to save hello world in any file, in some file. Let me call that file test.txt, right? So what this does is it will display hello world on the screen, on the terminal as well, and it will save this hello world in the test.txt file as well. So if I execute that, I mean, you don't have to compile shell script, so you just save those files. Once you have given the permission, you just run or execute those scripts. So if I do something like this, what it will do is it will go and write that into my file, and that is the test file. So let me see, it should create text file, and there is my test file, and it has hello world over there. All right, so this is how it works. Sometimes what you want to do is you want to maybe take an input from the terminal and then save that into file. So we can do that as well. So in that case, cat command is normally used to get input from the terminal and then save that into, I don't know, maybe another file, test2.txt. Save that, run that, and it's asking for something. This is new input. Press enter and terminate by Control-C. You terminate that. If we go back here to our temp, test2 is created and it contains our input, right? This is the new input, right? So this is how we do it. Very simple, very simple. These are the simple commands. You can write an ls command over here as well. So we can do something like this: ls slash home slash the name of the user, and if I run this, you can see that it has listed all of my contents of that directory, right? So we can do something like this. So we know this, these are the commands which we can do, and obviously I can do a lot of things with these. Once I get these, maybe I want to delete a pictures folder or a music folder, so I can write a command down here. So this command will run first, then the second command will run, then the third command will run. What we have to do is we just run this shell script, and all these commands will run in sequential manner, right? So this is what we can do. So I'm gonna go a little bit out of this conventional way of writing these scripts. So I'm gonna do some other things, since we all know the programming languages. So I'm gonna do a little bit of that to give you some idea of how you can use the components of a programming language in bash. So you can use if statements, you can use for loops, you can use arrays, you can use strings, manipulation of strings, comparison, so many things you can do. So imagine if you have combination of all these things along with your bash commands, how much you can do. You have a lot of freedom to do a lot of things, right? So this is one of the classes where I really wanted you guys to know how powerful bash is, and how your programming knowledge plus the bash commands can give you a lot of freedom to do a lot of things, right? So let's start doing something which is related to programming, right? And I'm going to keep it very simple. I'm not going to go into complex programming problems right now. I'm going to give you very basic introduction of how programming can be incorporated using bash, right? So the first thing normally is hello world. We have already done that, right? So we can do something like this, hello world. We can do that, right? You can also use printf. So you can use this command as well. So you can do something like this as well. Save it, run it, and you will see that hello world with echo and another hello world using printf. So you can do something like this, and you can use new lines over here like this as well. So it will now be printed in a new line. So printf is like cout in C++. So it has a lot of possibilities. I mean, you can do a lot of things with this, and so you can do something like this as well. So what I can do is I can comment as well. If I want to comment something, I can use a pound sign. So hash sign, you can do this, you can call it, this is a single line comment. I can do something like this, right? And if I do that, obviously it will not be printed. This is only for explaining your code. So you can comment something like that, and it's always a good idea to comment something, right? And then in order to do multi-line comments, you can do something like this. It's important that you make sure that you are doing it the right way, and the important thing over here to note is shell is very sensitive to your spaces. So make sure you put spaces in such a way that that are accepted by shell. This is a multi-line comment. So we can do something like this, and if I save this, run this, obviously it's not gonna show anything. So this is the way to show your multi-line comments. All right, so this is how you work with regular comments in your program, in your bash script. I'm gonna start working with variables now very quickly. So we have done hello world. The next thing normally which you do in your programming language after a hello world and comment is to start working with your variables, and then control statements like if statements, and then loops, and so on. So now I'm going to do all of them very quickly for you. So in order to declare a variable in bash, you don't have to do an int or a string or a float. You don't have to do that. You just name the variable, and that's it. So for example, I want to take a variable that stores value 7. This is my variable. That's it. You don't have to do anything. This is the name of my variable, and it will store number for me, number 7 for me, and you don't have to put any semicolon, right? It's that simple, right? And if I do an echo, I want to show echo, so let me do it two ways. So let me do echo number and see what happens. If I do that, you will see I got a number over here, right? It should display 7, right? It should display the value of that number instead of just displaying me the number, right? So if you want to get the value of a variable, what happened over here is echo took number as a string, right? So it just displayed this as it is. If we have to tell echo or any other command in bash that this we want to get the value of this variable, and this is a variable, you want to get the value of this variable, you need to put a dollar sign in front of that. So you do something like this, all right? So if I do this, if I run now, you get 7. So in order to access the value of a variable, you need to put a dollar sign in front of that, and then your program will know, okay, I have to use the value of that number, right? So this is how you normally do it. And if you want to add two numbers, so let me say number 1, and let me take another number, let me call it number 2, let's call it 3. And if you want to add two numbers, what you have to do is you have to use special parentheses like this, and let me do it in a simple way and then put parentheses. So what I'm going to do is, since I want to add two numbers, I will do number 1 because I want to get a value of number. So this is the value of number 1 plus dollar sign number of value of number 2, right? So if I do something like this, and if I go to my output, you will see that it will just take them as strings, and I mean take them as strings in a way that it will take the value of the first number, but it will take plus as a string. So it will not add them, it will start showing us something like this, but we don't want this, right? We want to add these two numbers. So what do we do in that case? Should we try a parentheses like this? How about like this? Let's try this. Nothing. We are going to get an error for that, right? Because it doesn't work like this. It doesn't work like this, right? So what if we put a dollar sign here? What will happen? Let's see. I'm getting an error, which means the command not found. So in order to add two numbers, if I want to add two numbers and I don't want to actually get a string, a plus sign as a string, what I can do is I can do something. So this is a special convention used in bash, and you have to follow that. Otherwise it won't work, because it's not a programming language, it's just a scripting language that you use. So you have to follow exactly what it says, even the spaces. You have to be careful about the spaces even. So in order to add two numbers, we have to use double parentheses like this, put a space over here, double parentheses over here, put a space over here, and remove this dollar sign. Let's see what happens now. If you see now, I got the result. I got the result, right? So this is a special way of doing calculations in bash scripting language, right? So what you do is you do number plus number plus number, whatever numbers you are going to add, and put them in parentheses with spaces between parentheses and a number, starting and ending. If you don't put spaces, some of the version of bash scriptings, they are going to give you an error. They will not give you the right answers. And then the last one is for calculating that, right? Putting that in a variable. So this result basically is going to be placed in a result, right? So it will be placed in some result, and then that result will be displayed. So just to cut it short, if you want to do some calculations, always try to do it this way. There are other ways as well. If you are comfortable doing that way, you can use that way as well. It's absolutely fine, whatever is making you comfortable. So I mean, this is one way of making calculations, and obviously, I mean, if you want to do something like this, I can do this. So to make it more readable, addition of two numbers is, and you do something like this. So if I do this, it will show you something like this, right? And you can just remove the space if you want, and you can do something like this, right? Similarly, if you want to do some other calculations, you can do it this way. So let me do a minus here, let me do a maybe multiplication here, division here, and let's add one more for mod as well. So let me do a mod as well, and let's display this. So addition, I mean you need to change this obviously. So this is what we have. So it displays us the addition, the subtraction, the multiplication, division, and the mod, right? And this is what we were looking for. So you can do something like this. You can add, put them in a number as well, and it works like this. All right. So this is how you can work with the numbers, and this is how you can do some calculations with it. So yeah, that's pretty much it. Similarly, I mean you can work with strings as well. So I'm going to remove this. So I can do a string. For example, let's take a variable called str, and I'm going to call it hello world. So, and I want to echo this. If I want to echo this, if I do str, you know what will happen, right? So it will just display on the screen str, but we don't want that. We want to see the value of this string, right? So if I do something like this, I end up getting hello world. If I remove a $sign from here, save it, run it, I end up getting an str, which makes sense, right? So in order to get the value of a variable, we have to do something like this, right? And if we run, and it will show us the value, right? So this is how we work with strings. This is how we work with numbers. Let's talk about quickly now our conditional statements. If statement, right? So I'm gonna do an if for you and an if else for you. Rest of them you try yourself. I'm not going to do everything for you because I really want you guys to get some practice. So not to just see this video and that's it. Try to do some stuff here and there. Obviously there are some exercises, but I'm going to solve few of them for you and leave the rest of them for you so that you can get some practice for that. So okay, so this is what we have, and let's do an if. All right. Okay, let's do an if. So in order to do an if, it starts with the keyword if. Then we use these brackets. These are the brackets that are used if you're using an if, right? So I'm gonna say if 1 is equal to 1, and it normally uses like this. You don't use normally 2 equal sign. Sometimes for 2 equal signs also work, but normally it use 1 equal to 1, and you need to put a semicolon here after that. That's pretty strange, but this is how bash is. It's pretty old. It's very, very old. And modern programming languages are obviously much more powerful than this, but obviously the required things you already have in bash, and you can do a lot of things with bash and the available commands for programming languages. So you do this, then you do an then, and in the next line you put whatever you want to. If this condition is true, you want to do something. So I want to do yes or equal, and you need to end the if also, that is by phi. Yeah, it's a funny structure, but this is how programming languages used to be in very, very old days, right? So there used to be no brackets and no nothing, no indentation. There used to be if and then phi to close if, and then there has to be a then statement. So if I do something like this, if I run this, you will see equal, right? If I do 1 equal to 2, if I do this, you will not see anything, right? Because there is no else condition. And if I want to put an else here, I can do that. I can do not equal and do this, and it's not equal. I do 1, it's equal. This is how it works. Yeah. So make sure that you put spaces over here between the bracket and the number, and after the number and the bracket. You need to put spaces. So most of the bash versions, they are pretty sensitive to these spaces, just like if you remember the make files we did for our modules, kernel modules, they are very, very sensitive to spaces, and some students actually approached me because it was not working for them, and it ended up that they were missing some spaces, they were adding some extra spaces, some tab spaces. So they are very, very sensitive. So old programming languages, they were very, very sensitive to special characters and spaces, and modern programming languages, not pretty much. You can put as many spaces in some of the programming languages. So yeah, so this is how your if works. Let's compare some variables as well. So let me create a variable. I'm gonna say number is equal to 7. If number And how do I get the value of the number? If number like this is equal to 7, it's equal, else not equal. Oops, what happened? Okay, save it, go here. Shell is not working. You can do it again. So cd temp and dot slash what's the name, hello underscore script dot sh, and it's equal, right? If I do 8 here, do this, not equal, right? So this is pretty simple, right? Okay, so now what I'm gonna do is, by the way, you can use this as well. Instead of equal, you can use dash eq, and this is much more readable, people say, and well, I believe that. So you can use that as well, and you will see in if in while loops, it's very important that you use this. Even in if statement, if you want to use less than and greater than, these are pretty, these become very simple. If you use less than sign or greater than sign, then you have to put another bracket over here, which becomes very complicated. So if I do something like this, I end up getting the same result, because 7 is not equal to 8. If I do 7 here, and I run this again, 7 is equal to 7, right? And you can say less than lt less than 7 is less than maybe 8, which is true, right? You can do many other things. Not equal, for example, 7 is not equal to 8, so that is correct, it entered here. So get used to these things. It's pretty important, because I was using an equal sign over there. It was pretty straightforward, but when you are going to do comparison with less than and greater than, not equal, then these are making a lot of sense. They make a lot of sense, because if you use these signs, greater than or less than sign, you need to put some extra brackets over here, because it's pretty sensitive, as I said, with special characters, and these are special characters. So you have to make sure that you go with English characters, dash EQ and so on, right? Okay, so next thing what we can do is we can tell if a number is even or odd. That's pretty simple, right? So we can do something like that. So a number is even if its mod is 0. So let's do that calculation. So in order to do that, let me remove this quickly. So what I want to do is I want to do number mod 2. If it's equal to 0, then it will work, but this will not work. Let's see this. So the basic, condition for being an even number, let's call this even, and let's call this odd, and save this, and then run this, and it's gonna say that integer expression expected, and it's just showing us odd, right? Which is correct, but it's showing us error over here, right? So let's do this 8, and it's gonna say us this, even though this is an even number, it's still not going into else, because there is something wrong here. And obviously, as I told you, in order to make some calculations, you need to use double brackets, right? You need to use double brackets, and I'm not using any parentheses here. So you do this, and you do this. It's always a good idea to put spaces between them, but sometimes it works without spaces. So if you run it now, it's even 9, run that, odd, so it works fine now, right? So it's pretty simple. As I said earlier as well, many times, maybe when somebody is doing it for you, things look very simple to you, and you will think that I can do it, no problem at all, and I can make changes here and there, and everything will work, because somebody is doing it for you. But when you start doing it, when you start writing this program from beginning, it will confuse you from the first word, from the first symbol. Should exclamation mark come before this or after this? Have you thought about this? No, nobody thought about this, right? But since it's written in front of you, you can take it for granted. You'll say, okay, that's fine, we can do it. But when you start writing this from here, your mind will be confused. Okay, exclamation mark was first or after that? right? So it's always recommended to do it yourself, do everything yourself, because otherwise it's not gonna help at all. Somebody doing it for you makes it very easy for you to see, and then you can copy paste this, no problem. But then if you start writing, it becomes very difficult for you, right? So make sure you write these things, make sure you do it in a way that you understand, give it different variations and try to see how it works. It's very important you do that way, right? Okay, so this one is working for us. What I'm gonna do is, let's work with strings also. It's called str and I'm gonna call it maybe, I don't know, hello, and let's compare this string with hello. So I'm gonna say str, which is with dollar sign, $str is equal to hello, and let me call it equal, let me call it not equal. Let's save and run this, and they are equal, right? They are equal. So I put 1 here maybe. If I do it this way, not equal, makes sense, right? Makes sense. So I can do something like this. I can compare two different variables of strings as well. So I can do something like this. Let me do it 2 here, and if I compare it with $str, let's see if it works. Let's see, right? So if I do, it says not equal. What happened? It should be working, right? It should be working. Why it's not working now? Because it's just the same string. I just placed that in a variable now, and it's not working. It happens to be when you are working with string, you need to put them in quotes with dollar sign. You need to put them in quotes like this. And when you run it, it says it's not equal, which is pretty strange, and we can fix it, don't worry. Did I save? I saved it. It's still not working. Yeah, I got it. For strings, normally what you do is you normally use equal to sign, and let's see now. Still saying not equal. Oh, I got it. str1, got it. Now it's equal, right? And it should work without this also, to be honest. Just to keep it simple, just to keep it same for integers and strings, I just want you guys to use this one. It should work with this one also. Yeah, so it works with this as well. It will work with this as well, but some of the bond shells, as I said, they don't accept double equal sign. So better keep it equal and put the strings in double quotes like this, right? Put it like this, run it like this. If I change the value of this one to something else, save it, run, it's not equal, which is correct, right? This is what we wanted. So you can do something like this with strings also. One more thing I want to tell you is to get values from command prompt, right? Command line arguments. So what I'm gonna do is, what I want to do is, I want to get two strings from command line and then compare them, right? So this is what I want to do. So for example, I want to do hello, and I want to do hello, and I want to compare them, right? So this is what I want to do. I want to get inputs from here and then want to compare them. So if I do inputs from here, you know that if you remember, we did this. The first one is 0, the second one is 1, the third one is 2. It starts with 0, right? 0, 1, 2. So this value is 1, this value is 2, and this value is 0. So in order to do that, what I have to do is I can just do this $1, because I want to compare the first argument, which is this one, and 2, which is this one, and do a $sign here, and 2, right? Let's do this now. Hello and hello are equal, yeah. So hello 1, for example, they are not equal, right? So you can take input from the command prompt also. So these are called command line arguments. So you can do something like this as well. So now we know that we can do it this way as well. So how about we do our yeah, we want to do our even odd number program again. So what I'm gonna do is I'm gonna do number. I should have saved that somewhere, and let's let's get that in maybe $1. If this one space $, double brackets, number mod 2 space dash equals 0, semicolon, then echo even, else echo odd fi. If I do this and I try to run this now with some number, maybe 7. 7 is an odd number, 6 is an even number, and so on, right? So we can take command line arguments like this as well. So you might have noticed that I did not put quotes over here, right, like what we did in the previous program, because we want to get this as a number, not as a string. If you want to get it as a string like we did in the previous program, you put a quote over there, right? So we can do something like this. I hope this is clear to you guys. It's not that difficult when you are running programs as simple as these, but sometimes it becomes complex when you are using different commands, and you are getting different commands, for example, from command line, and manipulating those commands and so on. So it starts becoming difficult then. Okay, so this is this. What else do we want to do? All right, let's go to loops now. Let's go to loops, and let's do it in a simple way first. So I'm gonna run a loop that will print for me hello world maybe 5 or 6 times, right? So I want to keep this number, and let's call it 1. You can start from 0 as well. And in order to run a while loop, there is a for loop as well. I want you guys to try it yourself. I'm going to do while loop for you. So I'm gonna do this, and of number, if number is less than 5, semicolon, and in order to start the body of while loop, you write do, whereas for if you do normally then, you write then. For while and other loops, you normally start it with do. The section you start is with do. If this condition is true, then this section will run. Okay, so I want to do echo hello world, and I end it by saying done, right? So this is a simple program. The only problem in this program is this will end up in a infinite loop, right? Let's do that. So it will end up being in an infinite loop forever, right? And why it's in infinite loop? Because number is not incrementing at all. It stays at 1, and it will always be less than 1, and it will be stuck in a while loop, in an infinite while loop. So I want to increment this number. I can do that. I know how to do calculations, right? So I can do calculation like this. I know this, like this, and inside this I will do number plus 1, right? I know this. So I'll put a space here, remove a space from here. I can do that, right? So this is how I do it, but there can be a problem with this. Let's see what happens. Command not found, yeah. So what happened over here? So what happens over here is I am adding the number, fine, I'm incrementing the number, but I'm not saving that number anywhere. Am I saving this number anywhere? I'm not saving any number anywhere. So normally what I should have done is, something like this: number is equal to number plus 1. In normal programming languages we do something like this, right? But I'm adding a number, but I'm not saving it into number again. So number plus 1 is saved in an arbitrary imaginary number, and it's not saved in number. So number always still remains 1, right? So in order to save it in a number, I have to do something like this: number is equal to this. I have to save it like this. Now I don't put a $sign over here because I'm not using the value of the number. I'm just saving the value in the number, just like what I did over here. For assignment of a number, we don't put a $sign here, right? Just like what I did over here, I don't have to put a $sign here because I'm assigning some value to the number, like what I did over here, right? Save it. Let's see what happens now. It works fine. It worked fine, and it displayed it for 4 times because I did it less than and equal. So I can start it from 0, and it will print 5 times. this, it will start printing 5 times, right? So this is how we run our while loop. Another way to work with the increment statements is to do, if I'm not wrong, you can use a let keyword and you can use number is equal to number plus 1. If I'm not wrong, it has to be like this. Yeah, it works like this as well. So you can use a let keyword as well to avoid that complicated parentheses. But I would ask you to stick to one of the ways you do calculation, and this is the right way to do calculation. It makes a lot of sense. It's readable as well. For me, it's readable, and when you get used to it, you don't get stuck anywhere, right? So this is how you run a while loop. It's not that difficult. Of course, I mean, if you look at it, it's not difficult, but when you start doing it, you might be confused. Okay, how to start a bracket, how to start the section, how to end the section. So if you get used to it, obviously it will not be that difficult for you. So this is how you use loops over here. We're gonna use do a few more things. I want to do an array as well, but before going to array, I want to explain it to you the string manipulations as well. So let's talk about strings a bit. We have already seen how we can compare different strings. What I want to do is I want to find out some other operations what we can do on strings. So let's have a string first. So I'm gonna have a string called hello world, and I want to work on this, right? So what I want to do is I want to find out the length of this string. So for that I can use something like this. I can do echo, and I can do something like this. So if I want to manipulate a string, I do something like this. So I work on strings like this. Let's see what this will do for us. If you see, it will just display hello world for us, right? It's just displaying hello world for us, but I want to see how many characters are there in hello world in this string. So I will do a pound sign over here, and if I do now, it will just display me 11, which is the number of characters from the string, right? So in order to find the length of the string, the size of the string, I can do something like this, right? And similarly, I can take this maybe from the command prompt as well. So let's try that. I'll do system admin administration. Press enter, and it's going to display, as you see, only the first 6 ones, right? Why it's doing that? Because when I put a space over here, this is no longer $1. This will become for me $2, right? So that's why when you are getting arguments from the command prompt, it's very important that you make sure that you get arguments in a right way. Otherwise, you might end up getting something like this. All right. So if I want to do something like this, what I can do is I can put quotes over here. Administration, put quotes over here. Let me increase the size of this, and press enter. If you see now, what it did is it took this as a one string and not the separate command line arguments. So if you want to get a string, you can do something like this, put them in the quotes, and they will be used like this. All right. So this is how you can find the size of a string by using a pound sign over here. What else we can do with strings? We can concatenate some strings as well. So for example, I'm gonna use built-in strings here, right? So let me do this. Oops. Let me do hello, and let me call it str1, str2. Let's call this word, and I want to concatenate these two strings, right? And I want to store that result in maybe result 3. So what I can do is I can concatenate two strings by doing str1 and $str2, right? If I do this and I maybe display that string as well, str3, and I need to put a $sign here. If I do this, save this, run this, you can see I get a hello world over here, right? This is a simple way of concatenating your strings. Don't put anything in between. It's just that you use something like this, right? If I want to put a space in between, I can put a space over there. I can do this, and it will display the space over here, right? So this is how you concatenate strings. Other thing we want to do is maybe Okay, let's convert this into lowercase. Let me use this as caps lock hello, and let's not do this. Let's do this. I want to store in str3 the lowercase hello, so I want to convert this into lowercase. In order to do a lowercase in bash scripting, since we are manipulating the strings, we do something like this. I will do str1, since I'm going to do operation on str1, and I will put two commas like this, let's see what happens. And I have to display str3 as well, so I'll do echo str3, put a dollar sign, save this, run this, and you will see that it has been converted into lowercase. So in order to do a lowercase of string, you just need to put two commas after that string within this thing. If you want to convert something into uppercase, let's convert str2 into uppercase. You will use the cap signs, two cap signs like this, do this, and it will convert word which was in sentence case. It will convert this into uppercase, right? And now sometimes you want to convert stuff into sentence case. So I want to do something like this, w, and I want to convert this into sentence case. If I convert this into sentence case, I use only one cap sign. I'll go and run that, and you can see that in sentence case, basically the first word is capital and other words are lowercase. So you can do something like this. So if you can play with strings in this way as well. You can manipulate strings just like this, using uppercase, lowercase, concatenation of strings. We already know how to find the size of a string. That can be very important when you are working with strings as arrays. Basically strings are character arrays, right? So if you want to play with strings in the form of arrays, it's very important to know the size of that array, right? So you can do stuff like that as well. What else do I want to know? Yeah, I can also use string manipulation on getting substrings out of a string. Substring means you want to get some part of a string from a bigger string. For example, if I want to get, for example, maybe el from this part, I have to do some operations on my string to extract only el from my hello, right? So I can do stuff like this as well. So in order to do, and this is called substring, right? So you get a substring out of your string. So in order to do that, we can save it in a string. We can just display it in a separate string as well. So I want to display a second a substring, maybe only el or just a part of that string, not the whole string. Just extract some part of that string and display that, right? So I can do something like this. Since I'm doing a string manipulation, I'll do something like this. And which string I want to work on? I want to work on str1. I use a colon, then I put over here the starting point. Where do I want to start extracting the numbers? Let me start from 1, right? And how many characters I want to extract, the length of characters. Let me extract 2 over here. Let's see what we get. If you see, I get el. This is what I wanted, right? I wanted to extract el from the bigger string, which is hello over here, right? First argument over here is, well, the first argument over here is the string you want to play with. Then the second argument over here is the starting point where you want to start extracting the data. Obviously it starts from 0, 1 and 2 like this. So since I started from 1, which is e, and how many number of characters I want to get, you specify the length over here. So I wanted to get 2, I got 2 over here. If I get if I do 4 over here and I run like this, it will get hello, right? Like this. So you can do stuff like this, and these string manipulations are used quite a lot in industry. Not necessarily you have to do it in bash all the time. You can do it in many other programming languages. It depends which project you are working, but obviously they are very, very, very important, string manipulations. Even in bash it becomes very important sometimes, because you might have to deal with directories and their names have spaces in between, sometimes underscores in them. So you might have to work with those names, and in that case you use string manipulations like substrings and length of the string and so on to work with that, right? Another thing we can do with string is to replace a character in a string, right? I want to replace a character in a string. I can do that. So for example, I want to replace E by A, right? I can do that. So in order to do that, I use the same way. Since I'm manipulating string, I will use these curly braces, and I'll just put slash. I'll put the forward slash. I put the character I want to replace, and then I put a slash, again the forward slash, and I want to put since I want to replace E, I want to replace E with the character I put over here, which is A. So I want to replace E with A in str1. So if I see now, you can see that I have replaced it with this one. If I put L over here, and if I put maybe Z over here, if I do this, you will see that only the first one will be replaced. Alright, only the first one will be replaced. First occurrence will be replaced by whatever character we are replacing it with, right? And you try it yourself how we can replace all of the L's in this case, for example. You try that. All right. So this is how we drew a string manipulation in our bash scripting. It's quite important, not only in bash, in all the programming languages. When I work on different industry projects, I'm working on some data science and machine learning projects. This becomes so important, string manipulation, when you are working on especially natural language processing, NLP, deep learning, and so on. It becomes so important that you know these, because you are dealing with characters, and those characters can be anything, and you might not need all of them. You might want to get rid of side words, they call. So it becomes very, very important. So if you practice this, it's not going to only help you in this course or in bash only, but it's going to help you in all the other programming languages as well. So you need to just get a concept that how strings work, how you can manipulate them, how you can do a lot of things with them, right? All right, that's it for strings. There are many other things we can do with strings, but I'm not going to go in detail. Just wanted to give you some basics of how you can work with strings. I want to work with arrays now. So you can have arrays in your bash, and obviously arrays are extremely important, and they are very, very useful. We know that. And I'm not going to explain what an array is. I'm assuming that you guys already know what an array is, and I'm going to just create an array and use that, right? So I'm going to create an array of cars, and it's a string array, right? I'm going to create a string array. So I'm going to call it Toyota, and then there are, by the way, no commas when you are creating arrays, and arrays in bash are starting with parentheses. They don't start with the bigger bracket, right? And then I'm going to use Honda, and maybe Suzuki, one more maybe, let's call it BMW. Okay, so we have something like this, and I want to print all the elements of this array. So I'll do echo, and I want to display this array. So when we are working with array, we use curly braces, just like what we did for strings. Strings are basically arrays, right? Character arrays. So I want to say cars or car, and I want to display all of them. So if I want to display all of them inside this bracket in the index, this is the index place, right? I'll display, alright, let's display the first one. So I'll display 0 over here. If I do something like this, let's see what we get. We get Toyota as expected, which is the first index. I'll get 3 like this. Oops. I get 3, and it's displaying me BMW 0, 1, 2, 3, right? What if I want to display all of them? If I want to display the whole array, either I go through a loop which will display me each and every character, or we have a shortcut. We can use @ as an index value, and it will display me all the values of the array, right? Pretty useful, right? This wildcard entry is pretty useful. So we can use something like this, and what else we can do with array? We can do a lot of things with array. We can run through loops in array and use these wildcards over here, and use indices over there as well to work with them. But I don't think so. I have to go into a lot of detail because I believe that you already know what arrays are and how they how they work actually. So I'm not going to go into a lot of detail how arrays work. But this is normally how you manipulate arrays. Try to do more stuff with arrays. Try to see how you can manipulate arrays with different characters. I'm running only string over here. I want you to work with maybe maybe character array, maybe character arrays, right? Where you have only one character, not Toyota, just only have T. Maybe try in numeric arrays also, and try to work on that. What else? Let me think what we can do with array. Yeah, I mean that's pretty much it. I want to find some useful example where we can actually use array in real life code so that we understand. Okay, let's try something like this. Okay, I want to get all the information into an array using ls. Okay, so what I want to do is, for example, just to give you an idea how we can use arrays in more useful manner, what we can do is I want to use an array of, maybe let's call my files, and I want to store my, let's call it content, and I want to store the list of or the content of a directory inside this array. So how I can do that? Let's try this. So maybe something like this, if I'm not wrong, ls and home slash this slash yeah, like this. Let's try this maybe, and echo content. Let's see what happens. If I'm not wrong, it should be like this. Yeah, so what happened over here is basically, and if I try something like this, if I try something like this and do this one, and I run this, I get all of them. That's perfect. Okay, so what I did over here is, this is exactly what I wanted to do, just to show you how useful arrays can be. I'm getting the content of this directory using ls, and I'm saving all of that content in the content variable, and then I'm displaying all the values of that content array, right? When you are dealing with, when you're placing values into an array, you normally use $sign like this, you normally do it this way. And it makes a lot of sense, because this is returning you a list or contents. It's returning you contents. It's not returning you a single value. It's returning you content over here, because it's returning you the list. So you want to contain that thing in an array. If you want to contain that in a single variable, obviously it will not work, or it might save only the first value. You try that and see how it works. But just wanted to show you that this is one way of getting benefit out of arrays in bash scripting, and using in combination with the command bash command. So you can do something like this, and when you have the content of all of this, you might want to go in a loop and check the content of each folder inside automatically, or save this file, save this stuff using cat. You can do so many things. I mean, it depends upon what application you are trying to create, what is the scenario, what you want to achieve. It totally depends upon that. So you can do something like this if you want. So yeah, that's pretty much it. I'm not going to spend too much time on arrays. I just wanted to show you something useful which you can do with arrays. And yeah, that's pretty much it. Now one last thing I want to work on is functions. There are functions as well. So yeah, you can write lines of bash commands over here, no problem. But then functions are useful because you might want to write something very complex and you want to use that somewhere else again. So you can write functions in bash as well, and that's pretty simple. You write a keyword function and the name of the function. For example, I want to add two numbers and I want to return the result of those two numbers. So I can do something like this. I know this, right? 1 plus 2. I want to do that, and it will return me that, right? And once you have created a function, you have to call that function as well, right? So oops, sorry, we have to do two of them. Like this. Don't want to confuse you guys because we are using this notation, so it's always a good idea to use this notation for computations. Okay, so we have created a function. Now we have to call a function, right? So if I call a function, I just name that function. I call that function. So I've called that function. Let's see what happens. Nothing happened, and nothing will happen. I mean, something has happened, but nothing will be displayed because we have not displayed anything. Now what I want to do is I want to display the result of this calculation. So I have to do an echo, right? So I'll do an echo, and I do normally echo in this way when we are dealing with our function. So the result of this function will be displayed by the next echo term, right? So it will return me some result, and that result either you can save that in a variable, or if I don't want to save that in a variable, I'll just display this, and I'll just put a question mark over here which says that whatever result is coming from here, display me that. I don't know what that result is. Whatever result you got from this variable, this function, just display me that, right? So if I run this, it will display me this. It's a very generic way of doing it. I mean, I just showed you a very generic way, but obviously you can store it in a variable, do some calculations on that. Obviously you can do that, and obviously these can be variables as well. You can have variables and pass those variables, and it can work that way as well. Or that I need to tell my function that I'm going to get. Okay, let's do it in a simple way first, and then we'll do the other way around. So what I'm doing over here is I'm getting parameters. This is how you get normally the parameters. You don't normally provide parameters over here inside the definition of your function. So let's work with the parameters, and then we'll go to command line arguments. So I want the first argument of my function to be this one, and I want to add that with the second argument of my function. I want to do this, right? But I haven't provided any argument or any parameter. So when you want to do something like this, you provide arguments over here. So I will do 3 and 4. If I save it now and I run it now, it will display me this. Now I'm not getting command line arguments. This is not the result of, let me just remove them. This is not the result of these command line arguments. This is the result of these arguments which I have provided to a function, right? So my first argument was in $1, my second argument was in $2, and similarly if I have another argument, I will put a $3 here, right? So I will provide these arguments, and then I run my code and it will work. In fact, it will be a good exercise for you if you take the command line arguments from here, pass them to a function, and get the result and show that result on the console. So once again, so take arguments from command line, like what I did over here, 3 and 4 for example. Take command line arguments from here and pass those arguments to your function over here. Try to do that. This can be a very good exercise for you guys. Try to do that. And yeah, that's pretty much it, I guess, for bash. What I wanted to do is I want to do a couple of exercises with you also. So I have created an exercises file for you as well, and let's maybe do that. I'll do a couple of them for you, and you guys do the other one. Oops, I don't want to show you the key. So this is the exercise file. So there are how many questions? 1 2 3 4 5 6, and this also has solutions. What's going on? Okay, so we don't see the solutions. I will not provide you the solutions, and I'm not gonna see the solutions as well, and I'm gonna do it for you. All right, so I'm gonna provide you this file, and I will solve the first 2 or maybe 3 for you, and you try the other ones. So there are basically 6 of them. I'll try maybe the first 3 for you, or 2 depending upon time. I don't want this video to be very long, and you try the other ones. It will help you improve your skills of scripting, right? So let's do that without wasting time. So what this is saying is, write a bash script for getting an input from user on command line as a number and display whether this we have done this, right? I think we have not done it using the command line argument, right? I think we have not done that. In fact, we haven't done it getting the input from the user on the command line. Okay, so fine. Okay, I'm going to show you something like this. So because the output is enter a number, normally if we take a command line argument, we don't show something like this. So I'll show you exactly the same output, how we can achieve this output. So let's do that. So okay, so we want to get a number and we want to tell if it's an even or odd. Okay, let's do that. So let's maybe write something for our even odd function. We know what that is. So I'm going to do if and I'm going to put some spaces over here, put a dollar sign, then two parentheses, we know, and I'm gonna take that variable from user in a number variable. All right, so let me assume that I have already taken the number from user, and I'm gonna do this. If it's equal to dash equals 0, if it's equal to 0, semicolon, then I will say the number is even, and else it's odd, number is odd, and then do a fee to finish this. Oops. Okay, so yeah, that's the simplest way of getting your even and odd number. Right now we need to get this number from user, and as our exercise is saying, we need to show a console to user and a prompt to user telling that please enter a number. Okay, so if you do it on a command prompt, using a command line argument, it will not ask user for this number. So okay, so there is a special mechanism to do that, and that is called a read. If you do read command and do a dash p flag for it, and if you then enter this one, it will ask the number. So enter a number. If I do something like this, it will prompt user to enter a number, and then user can enter a number like this. So if you do something like this, it should prompt. Let's run this and see. Let me clear this up. Okay, let me clear this up. Okay, you can see that it's asking user for number, and if I enter 12 over here, that's perfect. If I enter maybe 9 here, it's saying odd. This is exactly what we wanted. So in order for user to enter a number, you with a prompt, dash p is for prompt, you can prompt user with enter a number like this and ask user to enter a number, and you can use a read command for that. So if you do something like this, you will see something like this, right? And this is what we wanted, and I think we are done. See, that was so fast, that was so quick. Okay, what else? Write a bash script for getting two inputs from user on the command line as enter as numbers and displaying all the. Okay, so we need to get a starting one and the ending one, and we display all the even numbers. Is it even numbers? Even numbers, yeah, it's even numbers. Okay, so we do something like that. So I can say maybe number 1, do number 2, and let's change this. Okay, enter, I want to change this, enter the starting number, maybe enter the ending number. You can improve it. Okay, so this is this. We have the equation for this. I have to start from a number, so since I have number over here, let's make use of this one. So I'm gonna do a number. Number will be my number and a counter. So number is going to be end of number 1, since my number will be starting from the number I want to user has entered, so I will do it as number. And then I have to run a while loop, in fact not an if statement. So let's run a while loop first of all. So I will do a while and run a loop. You can program it any way you like. This is what is coming to my mind right now, and I think this is how I did it for the keys when I prepared the keys as well. So that is stuck in my mind. I'm just going to use that way. It might be different, I don't know, but I'm gonna upload the key for you which I created way back but if that key is different from what I'm typing over here, please don't mind that. In fact, it's better if it's different, because you will get two ways of doing the same things. All right, okay, so let's do this end of number, and I want to see if this number, because I want to compare these two numbers, right? I want to compare these two numbers in such a way that number is the counter for me. Okay, so if this number is less than the ending number, then while loop will keep on going, right? And this is what I want, right? Because I have the upper limit for me, which is in the second number, which is the number 2. So dash lt, and I'm going to, if this is less than my number 2, this is less than my number 2, then I will start the loop and I will end the loop, and I will write everything inside this loop. So let me keep this, and I will change it in a while. Let me see if this is exactly what I'm looking for or not. It's always a good idea to do an indent for your code. Indentation is always necessary. It's a very good idea to do that. It makes your code more readable, and I have to put a semicolon here. Okay, so I think it should be fine. It's just that I need to do an increment over here. So number, so I've taken the numbers, fine. I have put the number into this number because I want to use that as an increment, and maybe starting number user put is 0. So if 0 is less than maybe this one 20 or 10, less than 10, yeah, it will go inside. Number is 0, 0 mod 2, fine. If it's equal to 0, then it will go an even number. I don't want to display this. I want to display numbers, right? So I have to display numbers over here. So I have to do echo end of number, which is going to increment every time. And I don't want this, right? I want to display only the even number, so I don't have to display odd numbers, and I just need to increment my number over here. So I will do a number is equal to, you know how we increment that, right? So this is how you do calculations. So I will do maybe spaces, I'll do number plus 1. That's pretty much it, if I'm not wrong. Let's run this and see. So okay, enter the starting number. Let me start with 0 as the exercise said. Let me put this 10. Excellent, that's amazing. Let's do it again. 0, 20, and that's amazing. Okay, that's exactly what we were looking for. So we have changed our program to use a loop now and display us even numbers between these two numbers, and this is how you normally do it. Very simple. So I hope you understand what we did over there. If you haven't, try to repeat this video, see what we did over there. In fact, these exercises are for you. So I would actually want you guys to not use this video to see the key, see what I'm doing. In fact, what you have to do is you have to pause your video here, try to do these exercises again, and then go back to this video and see how I'm solving it, right? Okay, so what is next? Write a bash script that takes a word as an input from the user and checks to see if there are any vowels in it. Okay, if there are any vowels, print the number of vowels, and if there are no vowels, just play this if there are no vowels. Okay, that's interesting. Okay, so I'll do it over here. So we have to take a number first of all from the user, character from the user, and then based on that character, oh, that is a bit complicated. Okay, let's build a logic first. So let me remove all this. We do step by step. So first of all, I'm gonna take a string from the user. Maybe let's call it word, since it said word, and I'm gonna take it from user. So I'm gonna do this. So I'll take a word from the user, and then I have to see if that word contains a vowel or not. Is it like this, or it's asking for all the vowels? That takes a word, see if there are any vowels. Okay, so I'm not gonna use AND statement, I'm gonna use an OR statement. Okay, so fine, I have to display number of vowels, so I might need to take a count, I guess. So let's take a count variable as well, and let's start it from 0 because I have to count how many variables, how many vowels are there. Okay, so and I need to get, okay, so let's try while loop. You can use whatever loop you want, while, and I need to take another one, maybe something I want to use inside my loop, so I'll start it with 0. While I is less than, okay, so first of all, since I have to use string as an array and I have to go through each character of that string, I need to get the size of that string first of all. So I have to get the size of that, so I'll save that size in a variable now. So I'm gonna do, we know how to find the size of an array, right? So we can do something like this, and since I want to get the size of the word here, and I'm gonna put a hash here, pound sign over here. So this would display me the size, it would display me the word, and let's see if I, okay, so I have to compare it. So while I is less than, so let me use the same computation one, like this, while I is, since I'm comparing, I'm not doing any mod, I can do it like that maybe. So I can do something like that. So let's try that. I is less than, while I is less than the size of that word, too many spaces, okay, then do and close it as well, indent that, and what I want to do is I want to maybe check over here each and every word. Wow, that's a bit complicated. Okay, let's try. So for each character I have to, let's first see this, if this is working fine or not. So I'm gonna do an echo of maybe I, let's do that, and we need to increment I as well. So I is equal to this, and I plus 1. Let's see what we have. Okay, oh, it's an error. Integer expression expected where? Line number 8. Okay, so line number 8, it says there is an integer expression expected. What did I do wrong? Okay, let's see. Okay, less than size, let me echo size. Oh, okay, let's do this. Let's see now. I have to echo size first of all. Let me echo size to see if it's displaying fine or not. Then we'll go from there. Oh yeah, so it's like this. Okay. Oh, it's displaying size 0, so that's wrong. It shouldn't be like this. I got it, because I'm not providing any command line argument. If I do this, then it's displaying me the size properly, and it's then showing me the error over there in size. Okay, I can figure that out because it is like this. How about now? That's perfect. Excellent. So I don't have to echo size anymore. My while loop is working. So I am basically going through, if I see this again, I presented hello here. So 0, 1, 2, 3, 4, 5, and there are 5. That is excellent. So I am going through the while loop successfully, which means that this is working absolutely fine for me. What I have to do next is I have to make sure that I check each and every character. So I can check, I can go through each, no need for this. I can do each character now. So I will check if statement, and I will do this. So I have to use a substring. If you remember, I have to check each character of that string, and I have to check it with A, E, I, O, U, right? So I will do a substring like this, since I'm gonna work on word. I'm gonna work on word, and inside word I have to check the first one, which is I. I'm iterating through each and every word, right? And I'm gonna use one of them, first of them, right? First of them, so, length of them, not sorry, the first of them, length of them. So it's going, it will start with 0 and just one character from here. And I want to make sure that this is equal to, I can use maybe equal to A. So if it has an A, then I put like this, then I do, just to check if it has, if this one is working fine or not. If I have an A inside, then I want to display echo A inside. And let's see, oops. Alright. And since there is no A inside, it will not display that, which is great. And it's working absolutely fine. So I got A. So if there is an A, what I want to do is I want to increment a count, right? So I want to increment, instead of echoing it, I will just increment count. So I will do an increment, because since I found a vowel, since I was checking only for A, since I found a vowel, I will have to increment it. So I'm just counting it for A, then I'll count it for all of them. So count is equal to, just want to increment that like this. So count plus 1. So I found A, so I'm going to count it. Let's see how many A's does it count. And I want to maybe at the end echo count and dollar sign. Oops. Like this. Let's see. Fine, for 1A it's working, for 2A's it's working. Perfect. So we have found it for A. We have to just extend it for all the other vowels. So, and that's not that difficult, shouldn't be that difficult. So what I'm gonna do, I'm just gonna copy it, gonna use an OR in between, so pipelines like this, or in between, gonna check A and then E and then I, O, U, all of them. A, E, I, O, and U. A, E, I, O, U. Okay. So I think that's pretty much it. So it will display me the number of vowels. Okay. So let's see. I have 3 vowels, so 2 A's and 1 O. Perfect. If I don't have anything, then what? It will display 0. Perfect. So this is what we wanted, right? So this is exactly what we wanted, and we can just decorate it like this, maybe. Number of vowels, and that's it. 0, and with this one we have this one. Excellent. So this is how we had to solve this problem, and I guess we are done with this. So yeah, that's how, I mean, you can use combination of nested if inside the loop, and then using arrays. It's a very good exercise. I shouldn't have done it, to be honest. You guys should have done it, because it contains arrays, it contains the substrings, strings, it contains a while loop, it contains an if statement, and it contains incremental statements as well. So anyways, I think this is, maybe we have anything else besides this which can challenge you guys? Yeah, anyways I've solved this for you. You guys try it yourself. So next exercise, I'm gonna stop here. I want you guys to do, this is just an incremental sum, and then we have to find the maximum value out of it. That's not difficult. And for getting an input from one and displaying the user whether number is, we did this right. I don't know why we have it here again. Anyway, so try to do this, try to do some other exercises as well. Make sure you guys understand what is going on, make sure that you actually challenge yourself when you are doing this, because this scripting is extremely powerful, and we are going to, you're going to see in coming lectures how we're going to use this scripting to do automation in system administration tasks. So we might want to register the time user is logging in, then when he's leaving the system, then we're gonna use that time as well, and we are going to write scripts for that, right? And those scripts are going to be very useful as a system administrator. So try to make yourself comfortable with bash scripting, so that next time when we write scripts, at least you get an idea of how what I'm doing and how we are solving the problems, right? So please do that. And I guess I'm gonna stop over here. This is it from my side. Please go through all these things. Please go to internet, try some more exercises and try to solve them. This is gonna help you a lot in coming exercises as well, and it's gonna help you in your project as well, because I'm expecting you to get something like this in the project, and not something like this, but at least something that uses scripts and so on. So we're gonna talk about that maybe later. But before we reach there, hopefully we'll do a couple of more assignments, and then you will get used to this. So that's it from my side. I hope you guys understand this. If you don't understand anything, you know my office timings, please visit in my office timings, and if office timings are not suitable for you, just drop me an email, and I will see if I can arrange something else for you. And hopefully within this week you will find the marks of your assignments on the portal, so keep an eye on that. And yeah, that's pretty much it. Have a nice week. I'll see you in the next lecture. Bye bye.